Okay, today's lesson is section 8.4, areas of regular polygons. Before we get into the formula for areas of regular polygons, there's a few things that you're going to have to remember from past chapters. One of them is the definition of a regular polygon. So, a regular polygon is a polygon with all sides that are congruent and all angles are congruent. So all sides and angles are congruent. The other thing that you're going to have to remember to work these problems are the 30, 60, 90 triangle relationships that we learned in chapter 9. So if you will remember, these will be right triangles. The side across from the 30 we call the short side. The side across from the 60 is the short side times square root of 3. And then the hypotenuse is 2 times the short side. In a 45, 45, 90 triangle, both the legs are congruent because it's an isosceles right triangle. So I call these two lengths L, and then the hypotenuse is L square root of 2. So you are going to have to use those to solve these problems. A new definition is for an apothegm. This definition is a perpendicular segment from the center of the polygon to the midpoint of any side. Once we start looking at pictures, you will understand that a little bit better. But before we go ahead and look at pictures, I'm going to go ahead and give you conjecture 79. You will want to get this in your notes. It is a regular polygon area conjecture. The formula is 1/2 the apothegm times the perimeter. So A is the length of the apothegm, and P is the perimeter. Okay, so 1/2 apothegm times perimeter. Okay, so let's look at some problems. We are going to start with an equilateral triangle. Okay, so let's look at a triangle. This is what is given. You know that the base of the triangle is 14, which means all sides are 14. because it's equilateral or a regular polygon. When you identify what the shape is, I always recommend that you go ahead and write down the formula that you are going to use. Now, we do have two other formulas for triangles. Actually, Hero's formula would work great with this problem. Using 1/2 base times height would be a little bit harder because you don't know the height. But we're going to work it using 1/2 apothem times perimeter. All you were given is the length of 14. The apothem that we just learned the definition of is the length from the center. Now, we've not really talked about the center of polygons. What I want you to do is visualize this being inscribed in a circle, and it would really be the center of the circle. Okay, so I am going to draw in the apothem. It is perpendicular to the midpoint of the side, so I just made two lengths of 7. I need to find this apothem length. So I'm going to go ahead and draw in a right triangle. And because all of my angles are 60 degrees in a regular triangle or polygon, that means this angle down here is going to be 30 degrees. This angle up here will be 60 degrees. So I have a 30, 60, 90 triangle. The side across from my 60 degrees is 7. If you will remember to go from the side across from the 60 to the side across from the 30, which will be my apothem, you divide the number by 3 and multiply by square root of 3. So my apothem length will be 7/3 square root of 3. That is my apothem. So, now that I know the length of my apothem, I can plug my values into the formula. So let's go ahead and do that. So I am going to put in 1/2 times 7/3 square root of 3 times the perimeter, which is going to be 14 plus 14 plus 14, or 14 times 3. So what is 14 times 3? 42. So I'm going to say times 42. Now I get to simplify. So 3 goes into 42, so I'm going to divide 3 into my 42. I just did that. I know that it's going to be 14. 2 goes into 14, so I'm going to say divide my 2 into my 14 to get 7. So then I'm left with 7 times 7, which will be 49 square roots of 3. And that is as simple as my answer will go. The next example that I'm going to look at is going to be for a square. Which is a regular polygon. Again, if you know the length of the sides, you're probably just going to use side squared. But I'm going to go ahead and do this example so that you know how to use 1/2 apothem times perimeter. So in this case, let's say we're given the apothem. To be 4. And I will tell you, if the apothem is 4, that the whole length of the side of the square is 8, which means the area is going to be 64. But I'm going to go ahead and draw in my right triangle so you see how this works. It will be a 45, 45, 90 right triangle. And so that means this length is 4, the side is 8. I don't need to know the hypotenuse, but if I did, it would be 4 square root of 2. So to use the formula 1/2 apothem times perimeter, I'm going to plug in 4 for my apothem and 32 for my perimeter. I will divide my 2 into my 4 and then take 2 times 32, which is 64 units. So a square will probably be the easiest regular polygon area that you will find. The other one that I want to talk about is a regular hexagon. So we know a regular hexagon has 6 sides, and we know because it's regular that all angles are 120 degrees all the way around. So when I'm looking at the apothem, let's do a different color here. The right triangle that I will make will be a 60, 30, 90 right triangle. Now in this case, let's say that the apothem was given to be 5 square root of 3. So that's given. We need to find the length of the side in order to find the perimeter. So area equals 1/2 apothem times perimeter. We were given the apothem. It is the side across from the 60. So the side across from the 30 will be 5 using our reference triangle. Divide by square root of 3. So that means the length of my sides will be 10. So to fill in the formula, I have 1/2 times 5 square root of 3 times a perimeter of 60. I will divide 2 into my 60, and then I will multiply 5 by 30 and get 150 square root of 3 as my answer. Okay, I hope that you've taken good notes. I will check these tomorrow in class, and we will work some problems in class tomorrow. I'll see you then.